Sorry, I was muted. I did not realize. So actually today I don't want to do lead code. I want to practice these advanced data structures because I have a test tomorrow and the test is actually not easy. And they in a mock test they had like problems that required segment tree. So they can also ask some harder problems. I'm going to be practicing this today. Segment tree, try, and Fenwick. Fenwick tree is very easy. So I can also like skip this because if I know segment tree, right, then all of my things are done. I can do everything that I can do with Fenwick tree if I know segment tree. That's like a big thing. Try is important for problems that includes kind of prefixes or maybe some XOR related problems, maximizing, minimizing XOR. Can see you. Okay. So first, let's open some. Talk about segment tree. Okay. So what we do, we have an array of size n. Okay, this is an array. We want to do some queries like minimum, maximum, or maybe sum as well. Although sum can be fine, like using prefix sum, so that is not something we will use segment tree for, but we will use it for operations that are not invertible. And also we cannot do updates on prefix sums. So, but segment tree it also supports update. So what we do, we have a node which is a root node. This will consist like all elements from 0 to n minus 1. So this is like a whole range. If we're storing sum, then we are going to have the sum of all elements in this parent node. Then we have a left part and the right part. Now here we are going to split by half, okay? And here as well. And we will be keep doing that until this L equals to R. So this kind of these nodes, these are going to be of size n. There might be a possibility that there are two nodes here and other here. That is also possible. But ultimately we are going to have n leaf nodes, right? And they will be like the individual value of my array. But let's talk about height of this tree. So because we are kind of exponentially decreasing the range, so the length at max I can have like a log n length. So this is like a height of a tree. So it is going to be at max log n. Because of that exponential factor, I'm exponentially decreasing it by half. So if I talk about these vertices, right? So if I talk about root, then we have 2 to the power 0 vertex, 2 to the power 1. We can have like, this is like the worst case, 2 to the power 2. And this will go till 2 to the power log n base 2, because this is going to be the height of a tree. And I just know like this is less than 4n. Okay, so this is the upper bound for this whole thing. This is why we can use an array to store this whole tree, right? So our parent, if our parent is I, then child is going to be 2i. And then another child is going to be 2i plus 1. We are going to start root starting from 1. We can also start from 0, but then we have to take like plus 1 here and plus 2 here. That is also possible. Okay, let's go and build a segment tree. Okay, so inside a segment tree, we have a variable for the length, and so this is all private. I mean, doesn't matter if I'm solving a problem, but yeah, if I want a good design, then it's okay. Then we need a vector. Let's call it t. So this is like a vector. Now we will make a constructor. We can make this public, or maybe let's go with the structure, right? We don't need that, like any of those things, so we are going to be okay. I'm going with a whole array here, so we are going to be taking the whole array inside it, and this n is going to be the size of this array, and we are going to resize this t by 4 into n. It's going to be size, and we're good. We can actually do, and here we can put 0. But actually, to generalize it even more, let me do something like, let's use some more values. So I can take like, let's build for sum, okay? And we can adapt it. So this segment tree is for sum and range updates. Okay, so we are going to be using lazy too. Now I need a function that is going to build this tree. So let's also make that. So we are going to be having a node, value of the node. We are going to have left, we are going to have right. How do I define like maximum bound? Should I just take a value here, or I should pass? Let's use capital letters. Okay. Now here we need to see few things. So while traversing a tree, if I'm at the node which is completely out of range, it is completely out of this L2R. Okay. How will I update this? If L equals to R, then what I'm going to do, I'm going to update this tree. A good name is going to be tree, I believe. Less confusing and much better. Okay. Let's update this tree of this node. Let's make it equals to, well, I will be taking this array too. You don't know how to coding? What? I don't know how to, I know how to code. I know. I'm just building some advanced data structures. Okay. This is going to be whatever is this array. How do I get index of this array? Well, the index is going to be whatever is L or R, right? We can also have another condition, and after doing that, we can return from here. That is okay. We need to call mid, going to be L plus R by 2. Then we are going to call build on this 2 into node L mid L R R. Similarly, we will call this on mid plus 1 to R. So I'm going to child right now, equal to plus 1 for child nodes, and here we have to merge. So whatever is tree of this node, that is going to be summation of these two values. Okay, so now we are perfectly okay, but I need to return a value here. Okay, okay, I think this is fine. We have successfully built. This is how we build a tree. Okay, now we have to do, let's do query first. Okay, we need most of these things for query to just copy and paste. We need node, we need left and right current, and we don't need this actually in that case. Hi Thor, you also understand coding from you? हाँ, मुझे हिंदी आती है. अच्छी बात है, समझ आ रही है तो. If you want to ask something, you can ask. Let's make a query. So here I have to do few checks. If this L is greater than R, or this R is less than, so if my current range L, these are my current ranges, this is what I want to query, right? Let's name them. Okay, so I want to query L to R and I have I and J. So I have to check if L is greater than J. Okay, that means it's out of the box, out of the range. There may also be a scenario when this I is greater than, why I'm confused here, bro. We have IJ, we have LR. This is a range we want to find. So one situation is this L is greater than J. Another situation is this is over here, so this I is greater than R. Perfect. In that case, we can return. We will return 0 because we are querying for sum, right? Else, if this is completely inside, we have some range L to R, and if this I and J are completely inside it, okay, so I is greater than equals to, and then this is greater than equals to. So if I is greater than equals to L, right, and R is greater than equals to J, okay, in that case we are going to return whatever is that node of the tree, my sum, and then I will go to the childs. Same query, I need to return like the value, so 2 into node, then I to mid, then go to L to R, same, that is my range. Let's go to mid plus 1 to J. No one is watching our live stream. That's okay. I mean, there are 4 people watching right now, but your writing is very poor. You know what is this? This is just a random. I can't write with mouse. So sorry for that. Okay, so I go here. But how will I do this? I need to sum this query. Okay. I think query part is also done. Now what? You are same like me, Windows plus WSL. I used to be a Fedora guy. I have used Fedora for some time. Um, but I switched back to Windows because I also play video games and I cannot play games on Fedora. So I was dual booting, but फिर dual booting का उतना फायदा नहीं है. I mean, सारा काम जब हो रहा है WSL से तो क्यों ही यूज़ करना. So yep. So we did these things. We need few more things. Let me check whether this is like working or not. Okay, let's do a C out, and we will do. Let's also invoke the build function with node as one. One is cool. What is L2R? This is 0 to n minus 1. Yeah, that is correct. And we have this ARR. Okay, let's see if that works. We have to query. Let's query 2 comma 3 for now. What do we have? Oh, I should make it. I don't need anything as an input. Maybe that is okay. Oh, I'm getting some problem. What is the issue? Oh, because we have multiple elements. So I should take this node and then I should have 0 to n minus 1. Let's also make. Now we should be good. Node ij and then we have this range L to R. Okay. We are getting nothing. Maybe. Is that fine? I think so. It should be void list. Is Fedora better than Ubuntu? That depends on you what you want to use, but I found like Fedora is more stable. Updates are also faster if you want to use like the latest Linux kernel. And I believe Ubuntu is like they work a little bit different. You know, they take times to push updates. And Fedora has become like more commercial. Not Fedora. Ubuntu has become more commercial. Right? So they focus on that commercial part more. But Fedora is like, for me, it's better. We have some issue. Because of that, we have some issue. Should I return an integer value? Maybe. I don't have to do any of that. I can do something. Right? After calling this, I can store into node plus 3 of. Now we good. Where is L mid plus 1. That was okay. Mid plus 1 to R. We got 9, okay? It's working. Let's try 4 and 5. Just to make sure that it's fine. It's fine, okay. I think this part is good. Now we will go for lazy. We are going to do some updates, range updates in login. Okay. Let's use so I'm going to make a function that is going to look at the current lazy value. I also need another tree. Let's call it lazy. Also do same with lazy. For addition, if lazy is currently 0, then that is fine. I will generalize this tree later on, so that these values I'm going to generalize so that I can modify this whole template in kind of just by modifying, changing some variables here and there. Need a function that can look at a current value and then it can push downwards to the children. So what do I need here? I need what is the node right now? What else? I need the range because I want to go left and right. Use I and J. That is it. Now if lazy of this node equals to 0, then we can just return. Else, what are we going to do? Because this is like a addition thing, we are going to update the current node with like the size. How do I do it? So tree of node, we are going to add something. So whatever is inside this lazy, multiply by size, which is j minus I plus 1. Okay, that is fine. And then we are going to push lazy to the child. Do I recursively have to do that? I don't think so. I can do like, I don't recursively have to do that. I will check for every single time when I'm doing an update. I can put it here. Maybe while querying, I can put it here. So I just have to push it towards the child. Okay. So if I is not equals to j, then only do that. Do lazy of 2 into node equals to lazy of node. Similarly do with the other child. Okay, push down the value. That is, I think, okay. Can return from here. I don't know, that seems appropriate to me. So while querying, I can check for this whether there is an update. Fine. Now this is going to propagate, and also I have to update the current lazy value. Now this looks fine to me. Okay. This check is also good because maybe, but just switch. I want to switch to Linux. So what kind of things I need to know? You should know a little bit about Linux kernel. You should know some commands. I mean, switching to Linux, you should think about it. I mean, what do you want with Linux? You really have like some work to do, or you just switching, you just want to look cool. बस कूल लगने के लिए मत करना स्विच, क्योंकि मे बी तुम्हारे आधे काम होंगे नहीं उस पर. कुछ सॉफ्टवेयर्स मे बी उस पर अवेलेबल नहीं होते हैं. आई यूज़ लाइक अ लॉट ऑफ प्रोग्राम्स और काफ़ी सारी चीज़ें हैं ही नहीं, तो आई हैव टू यूज़ विंडोज़ फॉर दैट बिकॉज विंडोज़ इज़ मोर कमर्शियल. Although Linux has some good alternatives, but so just think about it. But you can always try. You can use WSL as I'm doing it, or maybe you can just dual boot and check it out by yourself if you want to use it. I think we good with lazy updates. Um, while we are building this tree, we are good. Let's update the tree. Okay. So we are going to be taking same thing. So what do we want? So if this is out of range, just return. Okay. No updates required. And if it is completely inside, then what we do, because we are pushing like addition updates, maybe I can just update the lazy, right? Maybe I can just go ahead and update the lazy. Let's make it I don't have to set the value. I need to just also over here, while I'm building, I'm good. Summing this value up. Okay. Sum this value. Don't completely update. But this one I can make it 0. Fine. Should I change like a value of a tree? Because for this condition, I think I'm good. Then I can go to mid I plus j by 2, and I can update for 2 into node, and I can go from j to mid, L to R with the same value, and here I'm going mid plus 1 to j. Now I want to update can I update the values efficiently? So if these are some nodes, if this node is completely inside the range, I will update its lazy value, okay? Whatever it is, and I can return. That is completely fine. Maybe I'm returning from here too. What else? I can go. Is this correct? Maybe I should push. So before updating, I should actually push. Is it? Is that good? Maybe pushing while query is enough. I need a little bit of help here. So Updating lazy is fine, but if you're at a node which else you go deeper until you find some node and you do like update lazy there too. That looks perfect to me, by the way, but I don't need it here, right? Maybe I can try something. Let's see how this works, okay? Let's make a little bit of a update. So my node is 102n minus 1. Then I have L2R and value. Okay. So what I want, we have these two things, 9 and 5. So let's make 4 and 5 plus by 2. Okay. Let's see what is their value. It's coming out to be 14 only. Not increasing. So this is update function is not correct. Am I pushing the value correctly? I'm just returning the tree node. Okay. Maybe I should push from here, right? So once I increase this value of lazy, I should push. Is it like the same? Yeah. This thing is correct. Okay. But when I do push, right? So this is not 0. This value increases. Need to see my mistake. Yeah, a little bit. I already have a template pre-made. Range query, segment tree. Let's compare a little bit. Let's talk about update. This thing is completely okay. This thing is, so I'm just applying tag. What is apply tag? So what I'm doing, I'm just getting tree node value. And I'm also what is tag value? Tag value is just value, and then we have some. Let's ask ChatGPT because I want to pinpoint my mistake. POTD, not really. I have not even seen a POTD. Matrix similarity after cyclic shift. M cross n integer matrix and an integer k. The matrix rows are 0 indexes. The following process happened k times. Even indices rows 0 to a cyclically shifted to the left. Forward. So this 2 5 has shifted to the left. Oh, rows are shifted to the left. 1 2 3 4 times. That to even indices, and odd indices shifted to the right. We're talking about rows, right? Okay, so this is shifting to the left, and this is going to the right. So after doing 4 cycles, what are we going to have at this fourth position? So constraints are, what do we have here? We just have to think about it. We are going to have, so we are shifting to the right. So we are going to have whatever is the current index plus k mod n. Okay, where we are going to have I is 0 plus k, which is 4, mod 3, which is 1. We're going to have 1. Not really. This 4 goes here, 4 goes here, 4 goes here, 4 goes here. Four times. What is k mod n? It is 1. K mod n should be 0. This is true, but values are same, so it's okay. See, for every index we have to check it. We will traverse this matrix. We will know whether the row is let me do it. We have to check something. Okay, now if I is odd, so odd may we are shifting to the right. Let's talk about shifts. Because we are shifting to the right, we are going to have which value at the current index? Let's talk about the let's talk about the current column j. What we are going to have? J will become after k shifts. We have 3 minus k. Three minus k minus 1 plus m. M is 3. We have 2. 2. Okay. So this formula is for odd indices. Okay. Now for even indices, the formula is going to be n plus k mod m. That's it. So we can check for this one. So we have 0. What is I'm sorry, this is going to be j and this is going to be j. Okay, so this is 0 plus 4, that is again 4 mod 3. 4 mod 3 is 1, so we are going to have 2 here. Okay, so now here we have to check whether the value is same after these things or not. Okay, so let's talk about the index. So here idx is actually j minus k plus m mod m. Okay, and if mat of ij is not equal to mat of I. So row is going to be same, but to be, and we are going to return false, and we will do similar thing for even case. The formula is going to be a little bit different because of the different shifts. Here we can do k plus, we don't need plus m here, and that is it, and we can return true. Okay, not inside of for loop. That is it. Question is simple. Seriously, I'm doing mod m. Where is the mistake? The mistake is in this thing. I have 0. 0 minus 3 is minus 3. Plus 2 is still minus 1. Okay, so this is coming out to be. Maybe this is a problem. Minus k. I need to do mod here. Maybe just do k mod m before, so that the value of k is not too much. Because it doesn't matter anyway, right? Because if there are 6 shift, that is equal to having like 6 mod 3, which is nothing but 0 shifts. Because 1 2 3, yeah, that's correct. Very easy. Let's see where is my mistake. Where is the mistake? Lazy and updates. Pinpoint. Lead code 310. And minimum height. You can choose any node of the tree as a root. When you select a node, the result tree has height h. Similar to yesterday's geek for geeks POTD. So I'm not going to be solving this. So you can solve this using an outdp. Okay, it's again very easy. I know this concept, so I can do this. Like this is rerouting basically. Or in this problem, there is a greedy idea, and the greedy idea is the minimum height is going to be the particular node which is in the middle, and we can do this using topological sort. So we will keep removing the leaf, right? There was a code forces problem actually very similar to this. I don't remember, but I think it was something in December. You said once we use rerouting, but I don't get it. So rerouting is a concept. You have to kind of read it out, like in out DP and rerouting. Rerouting is basically you can efficiently find some. For example, if you want to find maximum height, you need to use like a root. Then you will go from root to the leaves to find the maximum height. But if you will do this for every single node, the time complexity is going to be n squared. So rerouting is all about doing those things in like n log n time, or even big O of n. You can do this in big O of n using rerouting. I can show you like the code for this. So the code is very simple. You are going to have two DFS. First DFS, you are going to store whatever you need mm, for the subtree. So you should have that subtree ready. Then in second query, you are going to first of all store like two maximum. If you're going to find a maximum height, then you will store like uh, two maximum subtree values, so that if you are at a current max, you can switch to the next max. I will show you the code for technique. I think it's in my secondary account. It must be in tree algorithms, right? Yeah. Not this one. Yeah, see, this problem was about finding distances between two nodes, if I'm not wrong. So first of all, I find this in DP, which is basically all about the childs, storing whatever is the max for this particular child. Am I finding a diameter or something? I don't know. And then in the second one, I'm taking two maximums for every child because I have to update those childs. And then here I'm updating the out DP by taking out DP plus 1 and best plus 2. So this best is actually, we have this tree, we have these multiple nodes. So I'm right now over here, I'm traversing through all of these and I'm storing two best, okay, A and B. Now I'm again traversing and I go to this child and I see if this is equals to A, then my current will go to B, and then for with B I will update. So there is some B here, let's say, or some A here. What is the distance? What is the max? Whatever is maximum stored over here plus 2, because there are two nodes here as well, right? This is what I'm doing here. This is why I'm doing best plus 2, and out DP plus 1 is basically, out DP is coming from this parent itself. So you're just doing plus 1. So here you can use a kind of topological sort idea. So you start with a leaf, you remove these leaves until there are two nodes left, two or one node left. If the number of nodes, yeah, that is pretty much. Wrong condition in updates. Your condition is reversed. You are checking current segment inside update range. What the fuck? Update range fully covers the current segment. My bad. See, how funny is this? These both things are same. Seriously? ChatGPT? Lazy updates. Oh, so this I have to do. Okay, this is something required. And then I also have to update because I'm summing this up. Okay, my bad. Let's all the pending updates, and then I also update of node by these values. I think that is fine. Here I push 2 just by summing up the value. So this is correct. Excuse me, it did not work. This is absolutely fine. Same condition. Are these incorrect? Let me check. I greater than equals to L, I greater than equals to L, R greater than equals to. These are same thing. Like, what the fuck? The fuck? My condition is I greater than equals to L. That is absolutely wrong. What? But like, the fuck? R greater than equals to J. This allows invalid cases like T comma 10 because J is greater. Oh my god, this is yup. Everyone said, you're still alive. Yeah, I'm alive, thankfully. I have not been kidnapped. I'm safe till now. What the fuck? कुछ अलग ही इशू बना दिया इसने तो. Ass. I mean, ChatGPT is so dumb. I can look at my template. That's a better idea. Okay. So what I do when I apply tag, I increase it by length. Where is my push function? Okay. Talk about push. Absolutely correct. Then I go to a mid and I go to left and right, and then I apply tag. This is wrong, I believe, but let's see. Gemini thinks a lot. So go to left and right. Then I apply tag over there and I clear the tag. Do I recursively have to do it in push function. I think this should be just fine, right? This should be just fine because I'm doing it every single time. ईमानदारी ये बीमारी तोड़ के आजा छोड़ के आजा दिल करे तुझको एक बार सारी नाइट पे शर्मेगी. This is absolutely fine. I'm just pushing these values to the child. This is in a range, then child are also in a range. I is greater and I is lesser. Greater and R is lesser. Then you do a push on the old tags. Then you recursively go and update the node of a tree. Fine. भाई क्या कर रहा है यार, इतना सोचेगा. How much time? My god. Burnt chicken dominator geothermal. Is it tomorrow? Yep. Tomorrow 8/5. I will prefer giving lead code contest, honestly. So let me reach Guardian. There is no fundamental flaw. The missing modulo. I mean, in chat. Is saying that there is no issue in the code. Code is definitely incorrect. Literally, voice. My voice is fine, I believe. Yep. See, Gemini said it's completely correct. Then why my tree is not updating, bro? So if L is greater than R, J, or this I is greater than R. Return 0. God, bhai, fucking AI. Dumb as fuck. You have this block, the base case bug. In a build function, you have tree equals to. This is correct, but ensure ARR is always a 0 indexed to match your 0 to n minus 1 call. Obviously, getting wrong answer. Hmm. The condition was I is greater than. This is actually checking if current node's range ij is fully contained within a target range. However, your parameter in update suggest imid is the node range and lr is the target range. Of these or use them. This is update. What the fuck? Ensure your comparison is what's the issue? I is greater than equals to L. Guys, am I stupid or like this Gemini is also stupid? Just in case. I mean, let's say I'm stupid, so let me follow this. Okay. Anywhere else? So AI is stupid, bro. Because these two things are same. The return value in query. Because you're using push at the start of a query updates the tree node for the current level. However, if you don't call push for the children inside the child, you may get stale data. Okay. Let me just match. So pushing old text downwards. Can't believe AI is so shit. Can't even solve a single fucking problem that I have in my code. This is fucking insane. Update not happening. Okay. Look at these two inside of update function. The bug is here. But why? Because you missed the +1, the right child. Excuse me, what? Oh, fuck. Really? I missed the right child. Okay. Okay, that was the issue actually. So GPT told me that this is wrong because I wrote r greater than equals to j rather than writing j is greater than equals to less than equals to r. But my logic is good, so I'm happy. Now let's. Is this like a good segment tree? Let me apply it to some problem. Okay. Hmm. Let's go to CP algorithms. Maybe I find some good problems. Hotel queries. Range update and sums. Increase each value in range by x. The task is to maintain an array of n values and efficiently process the following types of query. Let's do this. What do we have? The first line contain 2 int n and q, the array size and number of queries. The fuck? Okay. Array size and number of queries. We have a initial contents of the array. So we have this. Okay. We have all these values, and then I believe I'm going to have q queries here for it. Now first letter can be 1, 2 or 3. Let's take the first letter. Okay. Okay, so now it depends. If t equals to 1, then do this. If t equals to 2, then do something else. Three cases we have 1, 2, 3. Take 3 values in all of these cases. A, B, C. Okay. Take 3 values here, and here we are going to have 2 values only. Okay. So first is increase each value in this range by x. Let's call segment tree. I just built segment tree. Let's call this on array so that it builds the whole array. Then we update. Okay. A, B, this value x. By the way, we need to push node 0 and n minus 1. I can make a function to do it. Maybe I can make another function here so that I don't have to do this like again and again. Then set each value. Okay. A comma B. Okay, we have to also do for like setting the value. Increasing I did. For setting each value, I need a different approach. To it. Let's talk about setting the value. The push function is going to be a little bit different if we're talking about setting the value. I'm going to clear the lazy. No, I will update the lazy. But if I'm setting the value, I will make this equals to, okay? But I have to process whatever. If we have something, wait a minute, what? So maybe I have like previous update. I don't care about a previous update. Also, I don't care about, okay? This is my push function, okay? What I did, what is going to happen to my push function? So here I'm summing this up. I don't have to sum, I need to update, right? We have some range. I'm setting up the value. I made the lazy whatever was the value, then updating it by the size of it. That looks very correct to me actually. Has to be correct. But then I don't have to do this plus as well here. Can I do that? Setting up each value. Okay. Hello. How do I set? I'm just a little bit confused right now. But queries is all about sum, right? Yeah. So just a difference about increasing the value. Where I'm increasing the value, that is okay. But here, I don't have to increase the value. I need a different push function actually in this. So maybe I can make another one. Push 2. Let's just put it that way. Now tree equals to this lazy propagates because I'm setting the value. That is all I need. But I still don't know, like, while doing a query, do I need to push? So this is going to be incorrect if I do it that way. If previous operation was set, I need to update the push function, I believe. I also wanna add that value in range bit. How do I set values? This is correct, but when I will push the value, it is going to push. I can't just remove it, right? Searching in a sorted array, rotated array, rotation, plain it. Searching in a sorted array is just binary search. Then what we have are rotated. If the array is rotated, what does it mean? Like, so if the array is sorted, so let's say current element is smaller and then it's getting bigger, or it might be like the other way, maybe in decreasing order. You can do binary search on it in both of the cases. Then you are saying rotated. So what do you mean by rotated? It's going to be like something like that. So first it can decrease then increase. Maybe it can increase then decrease. So either it is going to be like a uphill or like a downhill. Searching in this one, a bit tricky. I'm assuming you want answer in login. Wait a minute, let me check this. I need another variable for that. Okay. Only push if it is marked for an update. Okay, if this is true, then return false. Wait a minute. Why am I so confused? I can take the current value. Current value is a, I want to do a plus x. Another one, I want to make it x. To make it x, I can do a minus a plus x. Right? So I can see what is the current sum. And I can do x minus sum. Is that okay? Mm, okay. Do a query. And then I do a update. And in update, I will do c minus cur. Absolutely incorrect. With this array, then I have third. This should be correct at least. Approach explain कर दूं. But tell me now what you want to find. Are you looking for the peak? Are you looking for this? Or you wanna looking for any element? If you're looking for any element, then target element, okay. Rotated array. I think you're talking about this one. Search in rotated. And you have to do this on in login. Okay. So you are looking for any target element. Okay. Thing is, target element can be here or can be here too. You have two of such positions. I have solved this, by the way. When I was doing binary search, I did it. I remember. So my mid could be somewhere else, like anywhere else. Monotonicity is here, by the way. Like, if my mid is over here, I want greater. If I want like target is greater, right? Target is greater than mid. Then this is going like lesser, so there is no. It is of no use. Be like this as well. So what do you mean remember? Do you remember every single fucking 1,000 questions you have solved? You don't remember questions. If you're trying to remember these problems, then you're doing it wrong. I'm sorry. Okay, so the idea is that you first of all you have to find a peak, okay? And you can do it using binary search. It's very simple. Okay, listen to me. First you have to find this peak. And I already told you, I think, how to find a peak. You asked me before. So it is very easy. You just do a binary search and you look at left and right. If left is greater, you move to the left. If you're here, if right is greater, you move to the right. Once you have a peak, then you go ahead and do it. 0 to peak. Peak to n minus 1. Do a binary search on both. If not find in like either of these, then just return -1. So this is easy. Can also be like this. So it can also decrease. Then you have to go here and do it. So this is what you have to take care of. But maybe we can do it in like a single pass. Maybe we can do it like a single pass. Remembering approach. If it's like a very standard approach, then you do remember, but these kind of problems, they are not very standard, I believe. You basically learn how to think, because you will find a mid, you will end up somewhere. And if it is smaller, if your target is smaller, then it can either be here or either be here. So you cannot do binary search like this. You have to divide this whole array into two parts. If you have something like this, you have to divide this. You have to find this thing. And first of all, there will be a peak if your array is decreasing. If your array is increasing, and there is going to be like a downhill if your array is decreasing. So you have to divide it. Oh well, I did it in like a single pass. That is crazy. I have 2 pointers. Mid is greater. That means we have been a downhill. Hmm. If mid is greater than target, that means we go back. But L is also, target is also greater than L. Let's say my target is less. 0 is here, I is here, J is here, and mid is here. And my target is here. My bad. Uh, this is a wrong diagram. Okay. I misunderstood the question. This is a wrong diagram. You can have something like this, or you can also have something like this. And it is sorted in ascending order. So we only have this thing. Let's say you cut it from here, and then you are going to have something like this going above, and then something like this. Yeah, so this is the correct diagram. I thought. Now you start with I and J. Now you're at some mid value. This is, increasing. Have some target. Okay, now we can do it. See, if I'm over here and this is increasing, right? I have some target value. Let's say the target value lies here. So the target value is greater than mid, right? But the argument is that it can also lie here, maybe somewhere. Is that possible? Maybe it is not possible. This is going to be my lower bound. This is going to be my upper bound. Looks something like this now. Okay, so the thing is that you see these two elements over here. So this was a full range. The thing is the element can either exist on this one or on this one. It's not possible to have like the same range. That is not possible. Now we can solve this problem. Now we can check for some L2R. If target is greater than mid, then it is only going to exist here only. That is the only possible way. If mid is greater, that means sorted. Mid is greater than target, then we go left, obviously. Target is also greater than L. Or maybe target exists on left, but it is less than L. If it is greater than L and also greater than mid, then definitely it lies here. But if it is greater than mid, both of these conditions should satisfy, right? If any one of them broken, for example, it is less than L, that means it lies somewhere before mid. But how can we say that? It's not possible to have it greater and then less than, so yeah. Okay. So the thing is the bounds here. So these bounds were the things, because if you are breaking from here, then this left is going to be greater than or equals to this one. So we don't have something like this here, we have something like this. And now we can say for some mid whether we have to go left or right. Mixing diagram. Okay, I'm just explaining like one last time. So we had like an increasing array, okay, something like this. Now we are rotating this. So we can choose some random point. Let's say from here we have rotated. So now the array looks like this. And then from here we have rotated. Okay. So this maxima, it reaches here now. Okay. So this is our maxima. And see, this maxima is much greater than this. So the minima actually lies over here. So this minima, this is going to be greater than or equals to this value. So this is like a whole thing. You can start from here and from here. And this value is going to be greater than equals to this value. And this is the reason why we can tell for some target whether we have to move right or left. Because we can check for I and J and for mid as well. That is like the concept. मेट में प्लेसमेंट का क्या सीन है भाई, पता नहीं, बुरे हालत है. कल टेस्ट है मेरा इन्फोसिस का, इसीलिए मैं पढ़ रहा हूँ ये सेगमेंट्री वगैरह, क्योंकि इनके टेस्ट काफ़ी हार्ड होते हैं. मॉक टेस्ट दिया था, उसमें सेगमेंट्री की प्रॉब्लम थी, लाइक स्ट्रेट अवे, एंड नॉट लाइक वेरी स्ट्रेट फॉरवर्ड. दे हैड लाइक different things. You find the favorite number, find some Ramakan series, I don't know. So I'm getting wrong answer, right? Is it 0 index or 1 indexed? It's 1 indexed. So I have to. Is that okay now? Okay, my update is not fine. I think so. I did what? I did update. That is okay. Then I did query. That is also fine. Then I did set. How do I make this set correct? I have no idea. Reply about logic building. Solve more problems, maybe. What I'm doing right now is just logic building and nothing else. Okay, I'm trying to figure out how I can do both of these things in a single segment tree efficiently. So that is a part of logic building. So update. My projects are on GitHub, I guess. So you can go to my. I'm actually working on a project right now. And that is actually a good one, but उसमें time लग रहा है काफ़ी, तो जब हो जाएगा I will do a stream and share. Trying to make a clone of V0. Also, I'm taking help from someone, but I don't know. There are a lot of things here. I have to learn like whole agent kit. You know how I can get output from LLM and structure the output. And then according to the output, I need to also run up a machine in a cloud and then run a code inside a machine. And I have to do all of that thing automatically. So it's a good project I'm working. Currently, I have this a real feedback, and I also have another project, Mini Torch. That is a good one. It is just an implementation of chain rule in calculus. Basically, how backpropagation work in ML models. These are like uh, two projects that are in my resume. First is Mini Torch and then real feedback. So you can go to my profile. It's going to be you. I have used like a little bit of Gemini API just to get these suggested messages. You can send me like any anonymous message if you want to. This is the link /levish. This is my username, and you can send like whatever. Done. And once I log in, I can see this message on my file. Although I don't remember password, do I? Oh, that is my password. Oof the fuck. Mixing add and set. To make this work without losing your mind, tracking order of operations, we break the logic. That operation destroy history. If a node receives set command, it completely wipes out any pending add operation for the range. Add operation respects history. If a node, yeah, that is correct. Always put push set before add when pushing text down to the children. Apply the set tag first, then apply the add tag. Okay. चाय कोड ये वहीं से मैंने कॉपी करके बनाया, सीरीज में बनाया था। हाँ, ये काफ़ी पहले बनाया था मैंने। Tree node ARR of L. But that is like a easy one too. I mean, it's not very hard to make. But the one I'm working on right now is actually hard. So first I apply set. Okay. Set is true. Value. So I need too lazy. A new set wipes out any pending adds. Then I can make tree node of this value into the size. I add. If you're vibe coding, you're good. I'm not saying anything, but the thing is, I can also vibe code if I want to. So if you can vibe code, make something better than me, I can also vibe code and make something even better than you if I know what I'm doing. So it's always good to know, like, good to know the design that you're building. You know the design you can use. I use AI a lot. I use anti-gravity currently using, and the best thing about it is the auto suggestion. The code completion is actually pretty good. You straight away write something and you get this big completion that is almost correct. Like most of the time it is what you actually wanna write. So my push operation is pretty much the same. All I wanna do is, here I apply set, here I apply add. So my push operation changes a bit. Can't I just remove this thing is set? Like, I can put set as -1, right? Maybe. Okay, I can put this set as currently -1 because I'm never setting a value as negative. Better than cursor. The thing is, cursor is paid and anti-gravity is like free. You just use like 1 year trial, so that's what I'm doing. That is the main reason why I use anti-gravity. BevDev, but when I go to hackathon, I get mocked by vibe coders. Just start vibe coding, bro. Like, I mean, just build a design and vibe code. It's like not good for learning. So if you're just doing it for learning, then it's not good. But if you're building project, especially in a hackathon, then use AI as much as you can because it is going to help you. First, I apply set operation, and then I apply add operation, right? So here I'm going to do, first of all, I will see whether there is a set operation. That was the template, right? If these both are equal, I don't have to check it because I don't have to. Maybe they both are equal, I and j. In that case, I go to push and add it. I can add like, right, set and lazy can always return. So this is a recursive operation. I don't want to do that. No, this is not recursion. This is okay. I have to check if set of this node is not equal to -1. That means we have something to set. Now what I do, I apply set. I don't have to use these actually. What I do when I apply set, so tree of node becomes whatever is at set of this node. That is pretty much it. Right? And lazy becomes 0, right? I don't need it. Lazy set equals to value. What I'm doing? Oh, I'm just propagating lazy value, right? Okay. So tree equals to value into the size. And lazy set of this node equals to true. Okay, so this is for like, I'm applying this set operation to the children's actually. I can do it here only. I don't have to. I need a break, guys. So much cheating in OAs, and also OAs are harder, means questions are like 1600. Bro, I have seen it myself. Like Infosys OA, I mean, third question was of like 23, 2400 code forces level. I'm not even kidding. The second question was of segmentary, and it was not only segmentary. It was not like lead code fourth. No, I have to find maximum in a range. Then whatever is that maximum is, I had another function which was a Ramakan series. Let me search. Ramakan series, something like this. I don't remember the name. So it was like a custom series they have given, and you have to find something that the number of steps it takes for either the some value repeats, and the value is basically +1 if it's positive, -1, uh, -1 if coming out to be positive, -1 if repeating, or coming out to be negative, then +n. I mean, something like that. It was not very easy question. And you also had to brute force few things. Um, you have to find favorite numbers. Now, favorite number is a number that can add to some multiple of primes, and then your result is uh, either less than 10 to the power 6, or the result is also prime. So you have to find those favorite numbers too. So yeah, it was not easy. And it was like a medium problem, second. But actually, I did it. It took me like 1.5 hours. So what my push function will do, it will check set is not equal to this. But I did not update the value to the current one. I'll do it here, right? Push is for to push values down to the children only. My push function was for to even add value as well. So this functionality I'm transferring to here. So this is my set. Okay, update the tree node, update this, and we are good. Here we are doing apply add. I don't have to see for set operation, but set should become -1. No, I don't care about it. Wait, but that is it. But and he still plays in TCS digital. Cleared OA, still get ghosted. So it's just college thing. Opportunity. But he will get some opportunity, I believe. So that's okay. He will get something, right? I don't have to do it myself. I can just do apply that. I can push node ij value. But how do I apply it to like current one? Wait a minute. No, this is not correct. Yeah. It applies lazy value and tree value, but then I have to propagate those values down to the children as well. Is this working? So you apply set. The implementation is different from my implementation, so I'm getting confused. I'm gonna put push here, all of these. Fine. Push is all about pushing values to children. So my current is updated to these two things. Now I want to push value downwards. If set is not equal to, then what I will apply set to 2 into node I and j I and mid, and value is going to be the same. How I'm gonna have value here? Value comes from this set, right? So we already have something to the set. We already have this. All I'm doing through this function is adding the value to the tree. That's it. Also apply this to and it automatically makes set value Should I use my smartphone? Okay. I'm updating, so I do lazy of this node plus equals to well, and then I do apply add. Similarly, I can do this for the set. I will set this value equals to well, then I apply this set. Okay, set does what? It adds the value to the tree. Here we will set lazy value as 0 because I'm applying set. So if we had something to add, then we also have to propagate this value to the child. Taken this value, we have updated it. We will also propagate it to the child. But how? No, it's not okay. Someone is using washing machine. I will use my hotspot. If lazy of node is not equal to 0, and create this lazy thing. And when we talk about lazy, we always do like some. Okay, that is fine. Okay. Declaration issue. Lazy set conflict with previous. Okay, now everything is good. I had connect automatically on. What is the problem? Tree node is lazy set. Where is my previous? I can't use that. I don't know what's wrong. नॉर्मल डे में शेड्यूल यही रहता है भाई. कोडिंग कितने घंटे करता हूँ? 10 घंटे. You know what? Let me just ask. What is the issue? Okay, this is the issue. But oh, so the name was same even before. Like I have used a set. But lazy set is actually a good name. So let's go with this name. Then update set. Okay. So okay, we have a incorrect answer. Some logical flaw. You're very close, but that I have fixed. Double counting bug in add. Look closely, apply it function and how it is used. Inside it, I'm just adding the value. It was already added. This calls the add function. Oh, it passed. What the fuck is Gemini apping about? It is saying that the node, let's say, already has lazy set value 3, which was already added. If you do update with value 2, the lazy node becomes 5. But if it becomes 5, I have already added that fucking shit. 10 arm touch grass. 10 hour is not that much. Do I have this bug or not? If I have already added it, then I should remove it, right? While pushing values down to the children. Where is my push function? Okay, there we go. So once I have done pushing the value to the children's, I should make this lazy of node equals to 0. I can do it here, maybe even better. Now it must be good, right? Okay, that looks correct to me actually, but I'm not completely sure. Let's just submit it. Oh, we need a fucking file for that. Where the fucking file is? What's the name? Let's see. This is correct. Okay, this is incorrect. Obviously. Maybe I can check myself. Wrong answer. Correct output is, it's a big fucking expected itne got itne, so overcounting is the issue. I'm making lazy 0. It. What the fuck I'm trying to do? Wait a minute. Lazy value, apply the tag. double counting bug. You do an add of 3. Lazy node is now 3. You call apply add. It does plus now 3, correct. Later you do another add of 2. So my lazy is not changed. It should have. Oh, I did not just push it. Back to a new value. Wipe out any previous adds. Update function to pass. Update your base case and update SAT. But like difference क्या है? So I'm updating, then I'm setting the value. This is exactly what I did. Fuck. I think these two are the same thing. Something else. Update it, then I do apply add. I need to push the value down to the, but this push function is all this thing I need it. Okay, I can't just do something without it. Definitely need it. Directly with the new value and then updates the lazy array. X यूज करता हूँ बट नॉट मच, और जिम नहीं जाता. मैं जाता था बट अभी नहीं जाता. My mistake is what I wanna do. I'm increasing the value of lazy, and then I'm calling this function. Now what this function should do, this function should update the value, increase the value by whatever it is, then it should propagate value to its child. हॉस्टल में पीजी में रहता हूँ, कॉलेज के पास. I would like to do this. So here I'm just updating. Wipe out any pending ads. Set the tag value to a new value. This push function is just pushing my lazy. It is not adding anything. Pushing lazy downwards. So this operation is exactly the same thing, right? Setting the lazy value. Then I'm updating by this lazy value here. That lazy of node 0. I don't see the problem. Where is the problem? Problem is you see the lazy value and then you start updating its children's. And you should not do it. So when you updated this tree for set, I should push it to the children and leave it. This is what I should do. Guys, I need a 5-minute break. Pretty much need it. Title. Oh, we have a lot of options now. Be back. Okay, so I did a little bit of reason. The issue is that I'm adding whatever is in lazy, but lazy can have like the value which I have not pushed to the children and it has been updated previously. So one way to fix it is what Gemini telling me, just take value here so that you don't update it by this, you update it by what the value is. That is the first thing. Update it by the value and then sum up the lazy. Sum up this and update it by value. Do that. Let's push lazy set of node directly from here. So that the tree updates, also I will set this tree node equals to value. This is going to be equals to this because this is a set operation. Now lazy set of this node is going to be equal to value. I think that is good. Here as well, the same thing, we will increase it by the value and we will update this lazy of this node is equals to value so that we can propagate it downward. Now we are not over adding the value of the lazy node. Okay, do the same thing here. Okay, that is also done. Perfect. I don't explicitly have to do this. And where is my update? This was wrong as well. Let's just push value, it will automatically update. Now this should be correct. Where is the error? It got accepted. So what was the issue is the issue was in my lazy propagation thing. Let's talk about some other things now. Maybe, so how do I find the how many times the maximum is appearing? Let's generalize this first. This is a very customized. What I can do, I can create a merge function that takes two value. Now it returns. So in my case, this is a plus b, but it could be like maximum, minimum, or even set. Could be maximum, minimum, could be GCD as well. Let's use this merge function, okay, in query. So apart from this, I will call a merge function over these two. Okay. So this is good. Let's also use a tag value. Let's create few variables. Let's use lazy tag. So in case of addition, it is 0. In case of minimum, it can be int max or it can be int min in case of minimum. And I can use this lazy tag. This is my lazy tag. And also Assignment, I have to think about assignment? Because if I'm building maximum tree, then this also matters. So value tag is also something I need to store. I can remove lazy set for now because this was a very specific condition. And okay, we don't need lazy set. We have this in a push function. Updating it, pushing it here. This must be correct. Let's keep. Query update push. I think that is going to be that is correct. Now merge function, let's put it over here. Okay, let me do one thing. Let's put these constructors below, right? So this merging is going to be same or different. I want minimum. Let's apply these merges to these nodes too. Merge these two things together. This is in build. Let's also do it in update. And query is already good. So we should have like the same answer till now. Good design. Now we can also change these tags. This is how I'm updating a value of a tree. If I'm setting a value, I can just remove this part to be okay, and also this. If I'm going for min max, then what I will do? Not equal to lazy tag. Let's make it equal to lazy tag. I think that's a good one. Let's do it for min max now. So let's do it for max. Okay. So initializing by minimum, and I should have maximum. Is this fine? Not really. It should be the value of a tree. It should be what I'm updating. Wait, I'm updating the value. If maximum of a range, let's say, was 5, and I'm updating, let's say, 5 to it, then the maximum will increase by 5. Okay, so I don't have to do this thing, but This is going to be it. And then lazy off node is also good, I think. We may have some. This is what I wanted to update. And I'm pushing it to my children's. They will also do some by this. Is this not good? So the sum is perfect. No issue. Because we are adding. And then we may also have something to add. So this looks correct to me. Now let's say, what do we have? Maximum was 9. Then we added 1. Maximum was 10. That is correct. So we are doing 0, 1, 2, 3, 4. We're going until 5. Okay, 0 to 4. We have 9, 7, 8. Wait. Okay, 9 is coming from here. So we have 7 and 8. Correct. And then after summing up 1, it becomes 8. I think this is correct. Let's see if there is any bug. Let me ask. Any bug? Let's also look at my implementation. How I'm doing this, I'm applying tag. So this is similar to my implementation, like nothing is changed here. Range set plus range min. So merging operation is perfect. Maybe apply tag. Maybe there's something I can change. For range sum with range add. Maybe I don't have to do this, right? Renode equals to, oh, this is for range sat. Okay, my thing is correct. So this is not very hard. It's like easy thing. Be a little bit careful with lazy. Generalized template. A few works, including one will stop code from compiling, and very sneaky. Define your structure one at the top. What? You have 2 segment tree. Oh wait, really? Do I have? I don't have 2 constructors. I only have 1. Excuse me. query out of bounds. In your query function, your out of bound check is this, because your merge function find max turning 0. Oh my god. So I forgot to fix the base case. There we go. Look at your apply add function. Oh, this is a bug. If node is currently empty, node of lazy equal to tag. This is fine if this is equal to lazy tag. Equal to value, else I think this is now correct. Yeah. Okay. When I update, I just apply tag. That's it. Apply this tag, tree value, and update its lazy node. Then I will push. Okay, I think I'm done with segment trees. What else I can do? I can do some try things maybe. There was a lead code problem. Let's build a try for let's say Zor. I did it yesterday too. Okay, that is good. Let's build a try. So I'm going to make some nodes. This is going to be a node of, and it is going to contain a count value and going to have an array of size 2, which will create a constructor. So what count becomes 0 and ARR of 0, they all becomes null at this point. Okay. Now I create a structure for try. This is going to be a whole try. What do we have here? We are going to have a root node. Okay. We can take something like node star root, and then we can create this root equals to new keyword is fine, right? Just making a new object. This happens when I initialize the try. And I can use this root. Fine. Now I need some functions. Let's create a add function. So it is going to add this number x. Let's say the number is going to have 32 bits. So I will start checking from 32 bit only. And if bit is 1 or 0, so how do I check this? I can write shift x by b times, and if it is 1, then it's 1, else it's 0. But that is done. Now if, let's also take a current equals to root. We have to define data type for this as well. So node star current is root. Now we have to do if current of ARR of bit. Okay, if this is equals to null, then what we do? Make it a single name. We need to create a new node, right? And ultimately we are going to move to this new node, right? And after moving to this, we are going to go to account and increase the count by 1. That is correct. Add functionality is done, I believe. Let's go for max query. So this is for like maximum XOR, let's say. Works like things are going to be pretty much similar, but so maximum XOR. So this is the number that I have. I need to find another number that gives me a maximum XOR. To get a maximum XOR, I need number that is different. Okay, equals to null, or या तो ये null है. कैसे हो? बढ़िया है. आप सुनाओ, क्या चल रहा है? अगर ये null है, या फिर I can do something. I don't need a count. Don't even need a count. I can remove the nodes if I want to, but I think that is cool. Okay, that means we cannot do it. So I have some answer here. Answer is 0. And wait, what we do, what we do, what we do. We go to this bit then. If that is not there, then this should be there. And we don't do anything in that scenario. But else, nothing of them is that is true, then we can move to this not bit. Right? And also answer is going to end. I'm going to put B at that particular one at that particular index bit position. That is correct, right? I think so. We also need something to remove. Let's say this is the element. I want to remove it. How will I remove this element? This is one. If I'm removing, that means I don't have to check anything, right? I don't have to check anything. Just current equals to cur of ARR of bit. I think that is cool. Okay. I think this is a correct implementation. Let me ask Gemini. Is it correct for maximum XOR queries? सही में क्या अच्छे हैं क्या बाल? Thank you. Almost with a couple of critical bugs. Query function return type. Wait a minute. Absolutely. My bad. Out of bound starts at 32 bits. Yeah, I mean, I'm using long, so that's okay. Empty try, optional. I don't have to check it exactly. My code is correct. I need some problem. So I have this thing and make a try. Don't pass anything for now. And let's say I'm pushing some prefix or. Correct. This is also correct. This I don't have to. Okay. I need some problem that requires try. Tries or CSES. Okay, we have a question. An integer process queue queries in a form. What is the XOR sum of values? What is XOR sum? The first input line has two integers. When there are queue lines describing the query. What is the XOR sum of the values? What is XOR sum? What the fuck? XOR sum is basically XOR. What is XOR sum? Yeah, XOR sum is basically this. So this is all about. So this is a segment tree problem actually. I can do this using Fenwick tree. Let's do this. Let's create a new file. Let's call it Fenwick dot. Oh, just make a new file. Okay, let's take. Do I have Q again? Yeah. Create a vector of size n here. Let's take all the values. Do I have A of I? I have all the values now. Now I have to process Q queries. Message retracted. I don't know तूने क्या लिखा था, but तुझे फिर से लिखना पड़ेगा. Sorry. You have to. Let's build a Fenwick tree. Do we have size of this Fenwick tree? A vector. Okay. Let's quickly do the. Do I have? Let's not do it. Let's just take the size. So n equals to x and tree dot. Or do I want to assign or like just assign n plus 1 by 0? It is fine. Now let's create a function of. I can do point updates. So just to add. Now here I'm going to have cannot do range update. So let's take value and idx. Okay. Can use a for loop. So when I do addition, I will start with the range and then I will have to add the bits. Start from idx. What if idx is 0? Right? Start plus 1. I should be less than n plus 1 plus equals to I and I hope that's correct. And then what I will do is I will go to tree of I will increase it by value. That is it. Also, let's see. By the way, we have a XOR operation here. So let's also do query. I have L2R. We only have R here. We will start with this R plus 1. And then I should be greater than equals to 1. And I minus equals to I and minus I. So we are reducing it by LSP. Then I go to this tree of I. We were building an answer, right? So int, let's say sum initially 0. Then S XOR equals to I think we could. So doing that, I can return the S. Now we will do query. We have L, we have R. Now if let's say this is 0th index, okay, let's say R. If it's 0, we were absolutely okay with it. Let's find the prefix. This is going to be a prefix of L minus 1, right? But अगर 0 से बड़ा है, and then I can return T minus S. I think we good with this part. I don't need this vector anymore. I can just build a Fenwick tree. Size N, and then I can update this Fenwick tree. So we have indexed, 0 indexed. Right. Now we will do query. We have two things here. We have to see out and dot query L to R. Are they? No, that's correct. Okay. Some issues with the add function. Expects to. Oh, I have to specify the index of this. Now it's correct. Oh, wrong. This is fine. From 0 to that range. I don't think there is some operator precedence here. It should be correct. Where could be the issue? Oh my god, this is the issue. Well, my first query is wrong. 2, 3, oh. It's because of this thing. Okay, passed. I think that's correct. What's the name? Range or query? Yeah. That's perfect. Okay. And victory is like so easy. Let's talk about this one. XOR try CSES. Maximum XOR subarray. Given an array of n integers, your task is to find the maximum XOR sum of a subarray. I only need 5. I don't need 1. And then 9. Should it be added in basis? I think this is very easy. So I have n, then I have the array. And take this. This is not even like a try problem. I don't have to use try. Slice N, then I'll do it. Okay, so what I have to do, so this is like a maximum position we have. How do I find? Okay, this is a try problem. Good one. I can use it now. Alright, let's build a prefix OR. I think I need prefix OR. Is N, prefix of 0 is A of 0. Let's run the loop. Now prefix of I equals to prefix of I minus 1 is OR A of I. Prefix OR is ready. I will push this and I will, for every single R, I will try to find. Okay, let's build a try. Do I have to give anything inside try? It's empty. What I will do, I will not push anything right now. So currently the try is going to 0. Okay. If I query right now, what do I have? I do this and I get like null, maybe something like that. I need to do something about it. Okay, I think this is going to give me. No, I can push 0, right? We can always do that. Let's push 0 to the try. Add. Okay. This will prevent any sort of errors. Why I'm getting like. What is the problem? Must have a class type, but it has type try. What the hell? Request for member add and try, which is a non-class type of try. Don't get it. I'm trying to use. Wait, what I'm doing here? Conversion from try to non-scalar type. What the fuck is wrong? Are my oops concept? How do I initialize this try? I don't know what. This is actually very famous quirk. Most waxing parse does not see this as new try object. Instead, it interprets as function declaration. If you think telling it, hey, there is a function named try that takes 0 arguments and returns an object of type try. Trying to use a method on a function pointer. I mean, whatever. Let's take the x. Let's go to this try dot query and let's push whatever we have in prefix of r. Okay. We get it, and we have to okay. Now maxi is going to max of maxi comma x xor prefix of r. I think, and when I do that, I also have to add is the correct one. I have to add this prefix of I to it. I believe it's r, not I. I think I can see out maxi. Oh, when does this happen? I'm getting a wrong answer. Okay. Wrong answer. Answer is 0. Do I have like long or something like that? 2 to the 10 to the power 5 power 9. That is correct. What I can do? This is going to give me the same number because I am going x is going to be 0 right at first. Let me see what is this x coming out. Maybe something useful. It's coming out to be 5, which is absolutely correct. So expected output is 13. So I should get 13. What the fuck? Wait, what is my answer? So this should be x only, right? Because I'm trying to find कि x के साथ जोर करने पे एक maximum क्या आएगा. Okay, I think it's correct now. And submit it. Excuse me. Maximum XOR subset. Okay, so try is also good. Let's talk about this problem because kinda because I know how to do it. So this problem is about, so I can pick like anything. First of all, I will make XOR basis because the values we have can have like, let's say at max 32 bits. So we could have at max 32 XOR bases. That is pretty much it. But how do I find XOR bases? let's say this is my vector, so I'm going to store bases into this. But I need to XOR with every single one of them. Can always push the first value, I believe. No? Wait. What should I do? How do I build XOR bases? Okay. Its current value is V. We can XOR with, we will XOR with every single one of them. If this is not 0, then this is a prefix. Okay. Int B in basis. Right. So if V is not equal to 0, then basis dot pushback. And we are pushing back what? Whatever is left. We're doing like all the XORs. Greatly choose this. Okay. If in case answer XOR with this base, this is coming out to be greater than what the answer is, then I do it. Okay. I think my XOR basis is not correct. Let me think a little bit. So a basis is when you have some ones that is completely unique. Okay. Some bit that is completely unique, that has one and all of the other bits does not have it. So mm, my base is correct. This is also a base. So basis is all about I can't form, like I can't use some linear combination of these to make some other number. So all bases are going to kind of represent some dimension. So if I have 32 bases, I have 32 dimensions. So how do I add like a new base? How do I check whether that is going to be some linear combination of others or like completely new? I can start with 0. I can try forming this number. I'm doing the same thing. I'm taking this B. I'm XORing with every single one of them. It becomes 0. Oh, my XORs are incorrect. Bases are incorrect. Do I make new bases? Linear span. We have some vector spaces. That is okay. So I'm trying to minimize x here. If x is not equal to 0, then push it. Okay, so my mistake was that I will try to minimize this value. Okay. So I'm reducing the value as much as I can. Basis of phi. X using current basis vector. If this is not 0, add it to current base. And then my result is if it is increasing my answer, I will do it. Maximums or subset. So I believe it's 12 or 1. That is going to give me 13. Yeah. What do I have in XOR basis? One, 6, and 10 my basis. 1, 6, and 10 are my basis. So can't I make something better? 1, 6, and 10. So we have 1, 2, 2 ja 4, 2 ja 8. We have this. So 2 plus 4. Then we have 10. These are the bases that we have. Is this 10? 8 plus 2, 10. Okay. We XOR with this one increasing, so it becomes 1. Then we XOR with this one, it's again increasing, so we got this. Okay. By the way, I can, if I want, let's say, second max, how can I do it? I want, let's say, second max. Maybe I have some techniques here. 2400 rated. We use LCA. Use LCA with. Hmm. Door closer. Every teacher A and B in a set their bitwise or is also. So that means, so this whole thing is linearly dependent on these two things, because these two are bases, and then, I mean, we can find out the size of bases and return. This is the same solution, by the way. If X bit is the MSB of one of the element, it must be switched off empty basis elements after it. This is why this measure of reduction works without having to maintain the basis vector in sorted order. Okay. MSB of one basis element, it must be switched off in every basis element. Right? This is a MSB, this is a MSB. MSB. What if we have had 30? 15 will reduce to 12. So I think I did a lot of things today, so I definitely need some rest. Will also have to work on my project, so I will stream tomorrow now. Or maybe not. I have a test tomorrow. Gonna start at 2 p.m. So I may even not stream tomorrow. Also have a contest on lead code. Bye guys.